Day 431 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1751, maximum number of events that can be attended to. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array of events where events of I equals the start day of I, end day of I, and value I. The ith event starts at start day and ends at end day, and if you want to attend this event, you will receive a value of value I. You are also given an integer k, which represents the maximum number of events you can attend. You can only attend one event at a time. If you choose to attend an event, you must attend the entire event. Note that the end day is inclusive, that is, you cannot attend two events where one of them starts and the other ends on the same day. Return the maximum sum of values that you can receive by attending events. All right, y'all, so that sounds pretty simple, especially if you've been following along with this channel and we did maximum number of events that can be attended to. If you didn't do yesterday's problem, maximum number of events that can be attended one, which was yesterday's problem. So if you didn't do yesterday's problem, I suggest you go check that one out. It's easier than this problem and it's kind of a prerequisite to this problem. So if you were with us when we did that problem, you'll have a better understanding of doing this problem. So if you didn't do it, go ahead and check it out. I think that was day 430. Go ahead and check out day 430 so you can do the first version of this problem before you get into the harder, more difficult version of this problem. Now, with that being said, y'all, let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. And this problem, I can already see that one difference here is that the end date is inclusive, and that is you cannot attend two events where one of them starts and the other ends on the same day, where yesterday's problem, it wasn't like that. So that's just one of the differences. Now, with all that being said, let's look at example one. So in example one, we have our input events equals a 2D array of events, or a 2D array of integers. First array being 1, 2, 2, 4. Second array being 3, 4, 3. Third array being 2, 3, 1, and k equals 2. Our output is 7. Our explanation says choose the green events 0 and 1, 0 index for a total value of 4 plus 3 equals 7. So let's go ahead and break this example down one step further just so we could really make it make sense so everybody can understand what's going on. So these two, and we have our 2D array. Each array inside the main array or the initial array represents an event. So this is event 1, this represents event 2, and this represents event 3. Now, inside each of these event arrays, right, so the first index or the 0 index and index 1, these two indexes right here represents the start day and the end day. So this is the day it starts and this is the day it ends, right? So boom, same over here. This is the day it starts and this is the day it ends, and same over here. This is the day it starts and this is the day it ends. Now, this third element, which was not in yesterday's problem, represents the value that we receive each time we go to an event. So when we go to, think of it like points. Think of it, if we go to this event right here, then we get 4 points. If we go to this event right here, then we get 3 points. And if we go to this event right here, we get 1 point. And we want to find the maximum number of points or the maximum sum of values that we can receive by attending events, right? And then k over here too, that means we're only allowed to go to at most 2 events. We can't go to more than 2 events. It says right here an integer k, which represents the maximum number of events you can attend. So we're not allowed to go to more than 2 events, and we want to go to the events that's going to maximize our points or the values that we can receive, right? So in this case, if we go to event 1, which is this event, it starts on day 1, ends on day 2. We could do that, boom, and we'll get 4 points. Then we could go to this event because there's no overlap, right? This event ends on day 2. This event starts on day 3. So we could go to this event, and which starts on day 3 and ends on day 4, and we'll receive 3 points, right? We can't go to this event because this event overlaps this event, right? It says right here that you cannot attend 2 events where one of them starts and the other ends on the same day. So this event right here ends on day 2. This event starts on day 2. That will create an overlap, as you can see by this red bar right here. It's overlapping right here and right here. So we would have to pick between this event or this event, right? So we're going to go with this event because we want to maximize our values, and this event has a value of 4 while this event only has a value of 1. So if we go to this event right here, which has a value of 4, and we go to this event right here, which has a value of 3, 4 plus 3 equals 7, we could get 7, and that's the maximum sum of values that we can receive by attending events. Now, I hope that made sense, but let's take a look at example 2 just to really make it make sense even more, where this time k equals 2, but we don't need to go to all 2 events. We could get the maximum sum of values by only going to one event in example 2, and I'll show you how. So in example 2, we have the input events equals a 2D array event, 2D array of integers. First array being 1, 2, 4, second array being 3, 4, 3, third array being 2, 3, 10. This time k equals 2. This time the output is 10. Explanation says choose event 2 for a total value of 10. Notice that you cannot attend any other event as they overlap, and that you do not have to attend k events. So in this case, as you can see, this event right here, it starts on day 2, ends on day 3, right? As you can see in the graph, starts right here, day 2, beginning of day 2, ends right here at the end of day 3, right? And it gives us 10 value points. Now, if we can't attend any other events because of the overlap, right? So since this starts on day 2, this ends on day 2, right? So that's this overlap right here. Boom. This right here is where it overlaps, right? So since this ends on day 2, this starts on day 2, and it says right here, you cannot attend 2 events where one of them starts and the other ends on the same day, meaning that means we can't go to this event and this event because there's an overlap right here. Boom. Similarly with this event starts on day 3, and this event over here, this event ends on day 3, right? So that's another overlap right here. So we can't go to either one of these events if we want to go to this event. If we want to go to this event, that means we can't go to these 2 events because of the overlap, right? As you can see here. Now, that's not the end of it though, because if we could choose to go to these 2 events if we wanted to, and we just wouldn't go to this one. However, if we went to these 2 events, we would only get a total value sum of 7, right? Because this event gives us 4 points and this event gives us 3 points. But since we want the maximum sum of values, we could get 10 points right here. So this will give us 7 points. If we went to these 2 events, we get 7 points again. This be this 4 plus this 3. Right? Or we could just go to this one event and get 10 points, and 10 is greater than 7. So that's why we're choosing this event instead of these 2 events, because we want the maximum sum. So just in case that didn't make sense to y'all, let's take a look at one more example. Example 3, this is the last example. And in this case, there are no overlapping. So we can really make it make sense, or we can really get the best value for our points, the biggest bang for our bucks, by going to multiple more events than we would have been able to go to. So in example 3, we have our input events equals a 2D array of integers. First array being 1, 1, 1, then 2, 2, 2, then 3, 3, 3, then 4, 4, 4, then k equals 3. Now, since k equals 3, we can't go to all 4 events because we're only allowed to go to 3 events. Even though there's no overlapping, we only can go to 3 events because k equals 3. So we want to create the maximum value out of these 4 events, and those are the events we're going to go through. And in this case, the output is 9. Explanation says although the events do not overlap, you can only attend 3 events, and we're going to pick the highest value 3. So in this case, we'll go to this event because this event gives us 2 points, right? Then we'll go to this event because this event gives us 3 points. And then we'll go to this event because this event gives us 4 points. We want the maximum value of points since there's no overlapping, right? And so since this event only gives us 1 point, it got the shortest stick. That's just how the world works. It got the shortest stick, only gives us 1 point. When we want the maximum value of points we can get and no overlaps, that means we could go to all 3 of these. We could go to any events that we want, really, or we could go to any 3 events that we want, really, but we want to go to the events that give us the maximum value of points or the maximum value sum. So in this case, we're going to go with 2, 3, and 4, which is going to get us an output of 9. Boom. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. Now, the first thing for our solution is we are going to come over here and we are going to create, first thing we're going to do, we're going to create a binary search helper function, right? To find the first event whose start time is less than the target or the current event's end time that we'll get to further along in the code. So for our binary search function, we're going to call it, we're going to say private func. We're going to call it bisect right. We're going to open up the parentheses. We're going to say underscore events colon. That's going to be a 2D array of integers. Come outside that 2D array, we're going to say comma underscore target. Then we're going to say colon. That's going to be an integer, and it's going to return an integer as well. Then we'll open up the brackets. Then we're just going to do our simple binary search. Declare a variable called left. We'll set that equal to 0. Declare a variable called right. We'll set that equal to events.count. Then we're going to say while left is less than right. We're going to open up the brackets. Then we're going to find the mid. We're going to say let mid equal, open up the parentheses, left plus right. Come outside of those parentheses. We're going to divide it by 2 to find our middle element. Then we're going to say if events square bracket mid square bracket 0 is less than or equal to target. We're going to open up the bracket. We're going to say left equals mid plus 1. Then we're going to come right here and we're going to say else, open up the brackets, right equals mid. Then we're just going to come down here and we're going to say we return left. Boom. Simple binary search function. That's all for that. Then we're going to create another helper function. And this is going to be a recursive function to explore choices with memoization. So for that, we come underneath this. We'll call this private func. We call it DFS. Open up the parentheses. We're going to say underscore cur index. That's going to colon. That's going to be an integer. Then we're going to say underscore count colon. That's going to be an integer as well. Comma underscore events colon. That's going to be 2D array of integers. Come outside that 2D array. We're going to say comma dp colon. This is going to be in out, and this is going to be a 2D array of integers as well. Come outside of this parentheses, and we're going to return an integer. Boom, just like that. Now we need a base case for if no events left or selections remaining. We're going to say if count equals 0, or 2 vertical lines for or cur index equal events dot count. We're going to open up the brackets and we're just going to return 0. Boom. Then we're going to come underneath this if statement and we're going to return a memoized result if already computed. So we're going to say if dp square bracket count, sorry, that should be count, square bracket count, square bracket cur index. Come outside of that, we're going to say exclamation point equals, so does not equal -1. We're going to open up the brackets. We're going to return dp square bracket count, square bracket count, square bracket cur index, just like that. Boom. Now we need to find the next overlapping event index, and we're going to use our binary search function for that. So for that, we're going to say let next index equal bisect right. Open up the parentheses. We're going to pass in events, comma, events, square bracket, cur index. Come outside of that, square bracket 1. Boom. Now for the next, option 1 is we're going to skip the event, or option 2, we're going to take the current event and recursively compute the rest. So for that, we're going to come right here, and I'll show you where we're going to either skip or take. We're going to say dp square bracket count, then we're going to say square bracket cur index, then we're going to say equals max, open up the parentheses. This is where we're going to say dfs, open up the parentheses, cur index +1, comma, count, comma, events, comma, and dp for because it's in and out. And this is where we might skip events. Then next we're going to handle where we might take events, or take the current event and recursively compute the rest. So for here, come outside of that parentheses, but still inside the other parentheses, we're going to say comma, events, square bracket, cur index, come outside the square bracket, open up more square brackets and pass in 2. Then we're going to come outside those square brackets, say plus dfs, open up the parentheses, and we are going to say next index, comma, count, -1, comma, events, comma, and dp again because it's in and out. Boom. Then we're just going to come underneath that, and we need to return the computed result by coming right here outside of the parentheses. We could just say return dp square bracket count, come outside that square bracket cur index, just like that. Boom. Now we're not done because we still need to go to the main function right here, this max value function. First thing we're going to do is we're going to sort the events by their start date. Sorry, y'all. We're going to say let sorted events equal events dot sorted, open up the brackets. We're going to say $0 square bracket 0 is less than $1 square bracket 0. So once again, this is going to start by this is going to sort by the start date, right? So this represents each event, this represents each other event, similar to if this was for I, this would be for I plus 1, and then this is going to get the index 0, right? So it's going to go through this, and this will be the index 0, then it go through this, and this would be the index 0, and each index 0 is the start date, so that's why we're sorting them by the start date. Boom. Then we're going to say let n equal events dot count, which is going to get us the number of events. Then we're going to use our dp memoization table, which is going to store the max value starting from the index with the count selections left. So for that, we're going to declare a variable called dp, set that equal to a 2D array of integers. Come outside of that, open up the parentheses. We're going to say repeating colon, an array of integers. Come outside of that square bracket, open up more parentheses. We're going to say repeating colon -1, comma, count colon n, Then come outside those first parentheses where we say comma count colon k plus 1. Boom. Now we need to start our recursive function, our DFS function, from index 0 with k remaining picks. So to do that, we just come right here. We say return DFS, open up the parentheses 0, comma k, comma sorted events, comma, and DP. Now that should be all she wrote, y'all. Let's go ahead and give this a run before we submit it. Make sure it's, oh, okay. So what's say missing? Let's see where we went wrong already. Let me see, DP. So hold on, y'all. Hold on. Let's see what's going on here. Missing argument label DP and close. Let's see. I don't know. So we got the return DMF 0. Okay. Sorted events and DP. So DP, it should be repeating. I don't know what's going on, y'all. Let me see. Let's say on line 22. Let's see, missing argument. Line 22. Let's see. So we got hold on, y'all. Got the count. And we got the events. And EP. So what's this is a doozy, y'all. My bad, y'all. It's all part of the game, though. Oh, it's right here. This is missing an underscore. So now let's run it. See if that does the trick. Hopefully it does. And that's what I'm talking about. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 86 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see, y'all. So before we leave, make sure you get one more look at the code. This is the top part. This is this is the middle part. This is the DFS function. Boom. This is the bisect right function. Boom. One more time. Get the main function. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.